Welcome to another deep dive. Today we're going to be looking at a galaxy that's pretty far away.
Oh, yeah.
Yeah, 40 million light years away.
Wow.
That's right. We're talking about NGC 2090. And you might be asking yourself, why should I care about something that's so far away?
Yeah.
Well, NGC 2090 is helping scientists figure out how fast the universe is expanding.
It's amazing how this one galaxy can give us clues about something so big, the whole universe.
Yeah, and our guide for today's deep dive is this really cool article from the European Space Agency called "This Stunning Galaxy Holds the Key to Cosmic Mysteries." And it was published today, November 25th, 2024. And it has this beautiful image of NGC 2090 taken by the Hubble Space Telescope.
I saw that.
So while we're talking today, try and picture this galaxy in your head.
Yeah.
It's a spiral galaxy with what the article calls winding lanes of light, but it's not a typical spiral.
Right. It's not like those picture-perfect spirals you always see.
Yeah.
NGC 2090 is what astronomers call a flocculent spiral galaxy. Yeah. It's a little less organized than other spirals, kind of patchy and fluffy looking.
Almost like a cloud of stars.
Yeah, exactly.
Okay, so we have this flaky spiral that's millions of light years away, but how does that help us figure out how fast the universe is expanding?
Well, it all comes down to something called the Hubble constant, which basically tells us the speed of the universe's expansion.
Oh, so the Hubble constant is like a speedometer for the universe.
Yeah, exactly. It measures how quickly galaxies are moving away from each other.
So you're saying that NGC 2090 is like a mile marker?
Kind of, but instead of measuring distance on a road, it helps us measure distance in space.
But how do scientists actually use it to measure this Hubble constant? We can't exactly use a tape measure.
No, of course not.
Right.
But they have clever ways of doing it. One method they use is called the Tully-Fisher relation. Imagine you're looking at a lighthouse from far away.
Okay.
The brighter the light appears, the closer you know it is, right?
Yeah, that makes sense.
Well, the Tully-Fisher relation works in a similar way with galaxies. Brighter galaxies are usually more massive, and they spin faster. And by measuring that spin, astronomers can figure out how much light the galaxy is giving off, and from there, they can estimate its distance.
So they measure how bright and how fast NGC 2090 is spinning to figure out how far away it is.
Exactly.
And that helps them refine this Hubble constant, or the universe's speedometer.
Exactly.
Starting to get it now.
NGC 2090 was actually a really important part of a big project called Hubble's Extragalactic Distance Scale Key Project.
Wow, that's a mouthful.
Yeah, it was all about trying to get a more accurate measurement of the Hubble constant.
And they used NGC 2090 for this.
They did.
Yeah.
And back in 1998, they used the Tully-Fisher relation to estimate that NGC 2090 was about 37 million light years away.
Wow, 37 million light years. That's incredible.
It is, but then in 2020, they had more data and better technology, so they revised the distance to about 40 million light years.
So they got a little closer.
Well, not literally closer, just a more accurate measurement.
Right.
But the point is, these measurements using galaxies like NGC 2090 are super important for figuring out the Hubble constant and understanding how the universe is expanding.
So NGC 2090 is like a calibrator for our cosmic speedometer.
That's a great way to put it. It's just one piece of the puzzle, but a very important piece.
So even though it's far away, this one galaxy is helping us unlock some big secrets about the universe.
It really is. It's amazing what we can learn from these distant objects.
And that's just the beginning of our deep dive into NGC 2090. We'll be back with more after the break.
And you know what's really cool about NGC 2090?
What's that?
It's been observed by not just Hubble, but the James Webb Space Telescope, too.
Oh, yeah, that's right. I remember reading that James Webb can see things that Hubble can't.
Exactly.
So what does that mean for NGC 2090? What can we learn from James Webb that we couldn't from Hubble?
Well, think of it this way. Hubble is great at observing visible light and ultraviolet light.
Okay.
So it gives us those really sharp images of a galaxy's structure, like, the spiral arms, and those bright spots where stars are forming. But James Webb is different. It sees an infrared light.
So it can see heat.
Yeah, kind of like that. It allows James Webb to see through those big clouds of dust that block visible light.
Oh, wow. So it's like it has X-ray vision.
Yeah, you could say that.
Yeah.
It lets us peer right into the heart of those star-forming regions and see newborn stars that are hidden from Hubble.
So Hubble shows us the big picture, and James Webb shows us the details.
Exactly. We get the best of both worlds.
And when we combine the observations from both telescopes, we get a much more complete picture of NGC 2090.
Absolutely. Not just pretty pictures either.
What do you mean?
Well, having data from both telescopes lets scientists study the entire life cycle of stars in NGC 2090.
How so?
Well, they can see how stars form in those dusty clouds, how they evolve, and eventually how they die. It's like watching a time lapse of a galaxy's evolution.
That's amazing. So from this one galaxy, we can learn how galaxies change over billions of years.
Yeah, and remember, we're also using galaxies like NGC 2090 to figure out the Hubble constant.
Right, that cosmic speedometer. But why is it so important to know how fast the universe is expanding? I mean, does it really affect us here on Earth?
That's a good question. But the expansion of the universe is one of the most fundamental things about it. By understanding how fast it's expanding, we can start to answer some really big questions.
Like what kind of questions?
Well, like how old is the universe?
Oh, wow.
And what's going to happen to it in the future? Will it keep expanding forever, or will it eventually collapse?
Those are some pretty big questions.
They are, and the Hubble constant is key to figuring them out.
So this galaxy NGC 2090, it's not just a pretty picture. It's connected to some of the biggest mysteries about our universe.
It is, and it shows how even these faraway objects can teach us about our place in the cosmos.
It's like every galaxy has a story to tell.
And by studying them, we're learning more and more about the universe's grand story.
Well, this has been a fascinating look at NGC 2090 and its role in helping us understand the expanding universe.
It has, but there's still so much more to learn.
What do you mean?
Well, with all the new telescopes and technology, we're in a golden age of astronomy. We're constantly gathering more data, pushing the limits of what we know about the universe.
You're saying there's a whole universe of things we don't know yet.
Exactly. And who knows what other mysteries are hidden in galaxies like NGC 2090.
Right. It's like we've only just scratched the surface.
Yeah, there's so much more to discover.
Well, before we get too carried away, let's take a minute to recap what we've learned about NGC 2090 in this deep dive.
Good idea. Let's see. We talked about its unusual structure, that flaky spiral shape that makes it so unique.
And all those new stars being born in those swirling clouds of gas and dust.
Great. It's a really active galaxy.
And of course, we talked about how NGC 2090 is helping astronomers measure the Hubble constant, that cosmic speedometer that tells us how fast the universe is expanding.
And thanks to Hubble and James Webb, we're getting a much clearer picture of NGC 2090, its structure, its star formation, and how it's evolving over time.
It's amazing to think that by studying one galaxy, we can learn so much about the universe as a whole.
It's like a microcosm of the entire cosmos.
And like you said, this is just the beginning. There's still so much more to explore.
Absolutely. And with all the new tools and technology we have at our disposal, who knows what incredible discoveries lie ahead.
Well said. The universe is full of wonder, and with every new observation, we get closer to unlocking its secrets.
It's an exciting time to be studying the cosmos.
That's for sure. So to our listeners out there, we leave you with this thought. What other mysteries do you think we could solve by studying galaxies like NGC 2090? What secrets are they hiding that we haven't even thought of yet?
Keep looking up and keep asking questions. That's how we make new discoveries.
Thanks for joining us on this deep dive into the fascinating world of NGC 2090 and the expanding universe. We'll see you next time.